Morning, everyone. Hope you're all excited to be here as much as I am. Just a couple of disclaimers before we get going. These are forward-looking statements, some of them, so don't take them as necessarily product truth. Do complete your surveys. I mean, obviously, you guys are driving what not only we talk about up here on stage, but what we put into the product as well. And so this sort of information is really, really helpful to drive towards. So, okay, welcome to Comprehensive Data Management and Governance with Azure Data Lake Storage. With me is Santosh Pillai, I'm James Baker, we're both from the Azure Data Lake Storage team. And so today we really do want to talk about data governance, data management, and all elements around that, because the reality is data is this critical asset and we have to look after it. And so data governance is going to be all about that. And the first thing I do want to emphasize to everyone is the importance of data governance. You know, the reality is all our pipelines, all our ETL jobs, all our BI dashboards all work without it. But the reality is, again, that data is the critical asset. And so we have to govern not only what is in the data, but how that data is used, how it's protected, how it's aged on the system. All of those aspects that come into true data governance is deeply, deeply important. And so I really want to stress everyone should be concerned about data governance as an issue. ADLS does have a number of key capabilities that are already built in there that directly support data governance issues. It also does it in conjunction with a number of elements in the sort of platform stack, including Databricks, Unity Catalog, all of those capabilities. But on its own, you know, when we think about a disaggregated storage and compute model, the storage has to be responsible for some of those data governance aspects in isolation, and so ADLS has capabilities that meets that. And then finally, we certainly acknowledge we're on a journey with data governance. I don't think anyone can put their hand on their heart and say, we have the best data governance in the world, everything's locked down as tight as it can possibly be. And so as we go through this journey, we obviously think about what's next that goes into the product, but at the end of the day, it is you guys that drive what goes in there, and so we want to start discussions with you about how we improve and where we go to in the future. So data governance, as I say, you know, it's easy to think about data pipelines and data systems in the absence of data governance, but I really want everyone to say data governance is one of the core capabilities that we need to build into these systems. Otherwise, the consequences are nasty. You know, the textbook definition of data governance is a structured way of ensuring data quality, security, and compliance, and that's certainly true. But it is much, much more than that. And actually today, I'm not going to talk so much about those aspects. I'm going to talk about some of the other aspects that we certainly think about going and contributing to the data governance landscape. And some of those things are things like data protection. You know, if this is a critical asset, you know, you don't think about not having backups for critical assets. You don't think about not having sort of a life cycle capabilities around these critical assets, not just from a sort of cost management perspective, but from a retention perspective as well. You know, you don't want to be exposed to liability of inappropriately storing data in your systems, and so you need automated systems in order to make sure you're managing that life cycle. Observability, how is the data performing? How is it being used? How's it sort of evolving is also critical in that part. And then data access, people do sort of intuitively think about data access as a data governance quality, and we're going to talk about more today about how we drill into that as well. But there's much, much more that goes into data governance than just that simple textbook definition. And in the absence of comprehensive data governance, we really do think about the data swamp as the alternative. You know, folks that have been on this journey from the Hadoop days will recall, you know, it was fantastic at storing infinite amounts of data, but no one knew what the hell was in there. No one knew where the sales data actually was, and I've got 15 copies of the sales data, which one's the right one? All of those things largely were absent and really led to the failure of some very high-profile projects. And so, without being able to discover and understand the data, the value of that data is completely degraded. Security, obviously, we can't think about storing critical assets in a data system without being able to secure it, audit it, really have the ability to control who has access to that data. And so, again, that flows through a governance layer because sort of bit-tweaking individual ACLs is ultimately not a sustainable model. Availability, how is that data? If my enterprise is reliant on these data assets, I need to make sure that they're available. In the event of failure or disaster, I need to be able to make sure I can recover from that. And I need to do that in a governed way because not all data assets are equal. Some data is entirely derived. If we lose it, we can just rebuild it. But other data assets are core assets of the enterprise and must be protected. And then, as I spoke about before, things about life cycle are certainly essential elements that we need to flow into that stuff. The other thing about data governance is that it gets a bit of a bad rap because it really is sometimes very daunting. When I've got tens of thousands of data assets sitting in meshes of data lakes and so on like that, how can I get my head around what's in there and how do I secure it and how do I govern it? And the reality is you don't. What you do is you build policy, and you have policy bind to data that gets classified through automation, and that's what gives us the scalability. And then the other great thing about policy is that it allows a sort of a certain tiering of capability, and so we might be able to support the notion of centralised policy where the entire IT staff says everywhere we have to have certain aspects around protection for certain classified data. But then that allows individual data owners to certainly augment those policies and express their own policies around the data that they know best. And so policy is the way that you don't need to boil that ocean. You can do this in a scalable way and still be assured that you get comprehensive coverage. So now we're just going to sort of drill into a couple of aspects of those things that we've been speaking about, and specifically how ADLS looks at them and supports them today, and then how it's going to improve that going forward. One of those elements is data protection. As I said at the top, if you've got critical data assets, you need to make sure they're protected. And when we think about protection, we actually think in three broad categories. There's obviously sort of accidental mutation, someone fat-fingered a delete, or someone made a sort of, misjudged SQL statement that suddenly deleted a table. And so, Delta Lake and Iceberg, the OTFs certainly give us a lot of capability in that regard. They give us time travel capability. We can code backwards and restore from that sort of stuff. But you still need protection at the file system level. Someone can still delete a directory and suddenly all that data's gone. Someone can delete a storage account and that data starts to go away. And so we need protection against that sort of form of behaviour. The other thing, given we're all running in public cloud, you're not babysitting the individual servers that are storing this data. We do need to deal with the capability or the possibility of infrastructure failure. And so in this, we do think about two classes of infrastructure failure. Generally, within a given zone, we have zonal resilience, and so we've got three separate zones. That's not a redundant model. That is, three copies of the data are written to three separate physical buildings, and so we can lose a physical building and the data remains available. And so we certainly think about aspects of high availability. But we also think about if there's an earthquake in the region where your data is stored, we need to be able to fail over to a separate physical geographic region in order to keep that data and recover from that disaster. And the final threat is a little bit underestimated in my experience. is the malware ransomware vector. We all know that there are bad actors out there, and the possibility of them gaining access and compromising your storage account, quite trivially re-encrypting the data and saying you get that data back for X millions of dollars, is a real threat. And so we do need to mitigate against that, and the way we mitigate that is by physical isolation. And so we think about protection mechanisms that give us physical isolation in order to sort of protect against that. And so ADLS actually, as a platform service, does have quite a complex array of different capabilities that speak into those different categories of protection. Certainly we have vaulted backup. One of the things about vaulted backups is it covers all areas of protection, but that isn't necessarily the requirement for everyone. And so we've got other capabilities that layer in there. For instance, ZRS storage gives us that zonal resiliency that I just spoke about. Soft delete can sort of protect you from the fat finger delete operation, and so on like that. But the key point about there is that everything other than vaulted backup only gives you partial protection against those three classes. And so when we think about driving into comprehensive solution, we do think about vaulted backup as the capability. Good thing about vaulted backup is that anyone that's spent any time with infrastructure understands the semantics of backup. You back up the data, you can recover that data, it's pretty straightforward. Certainly in ADLS, it's a little bit more nuanced than that because you don't do a copy of the data every time. The data is being continuously replicated off to the backup vault, and then we create recovery points that allow you to restore from. But it is sort of still a very familiar experience to everyone, or to folks that have got any background in this space. But the critical thing about vaulted backup is that it does give you the isolation. So that when that bad actor gets into your primary storage account, they don't automatically gain access to your replica, which some replication methods do allow that sort of thing. And so vaulted backup is that level of isolation that, when someone's ransoming your core data for X millions of dollars, you can say, well, goodbye, we'll restore that data that we've got, and we're guaranteed to be in good order, and you can recover that data. And so, as I said, we do have, by design, quite a sort of matrix of capabilities. And as I say, they are there as a platform to meet all of the needs of all of the customers and the partners. But when it comes down to simplifying it, we want to offer a single solution. That single solution is vaulted backup in combination with ZRS storage, gives us a combination of high availability through zonally resilient storage and all of those qualities that we just spoke about in backup, and that's what gives us a single turnkey solution. Next aspect we want to talk about is the life cycle of the data. And life cycle is a little bit interesting because, the title of this talk is Data Management and Data Governance. And so when people think about data life cycle, they don't think about it so much as a governance perspective, and that's legitimate because a lot of life cycle capabilities is about cost optimization and sort of the true management aspects of your data. And obviously that's important, and so we want to be able to support that from a life cycle perspective. But there is a governance dimension in there in terms of retention. Certain data is mandatorily required to be retained for certain periods. Other pieces of data is mandatorily required to be expunged. And so these mechanisms have to be able to facilitate that sort of capability. So we've got a demo around some of the automated lifecycle aspects because it's great that we think about it, but it's also going to emphasise that this doesn't become a management burden in driving this stuff.
Hey, thanks, James. So at this point, more than halfway through our presentation, some of you may have been wondering, what is this guy doing up there? So I'm trying to demo the data lifecycle, a simple, very simple scenario of data lifecycle. It's a good segue from what James have just talked about. So let's try it. This morning, we woke up early and made our prayers to our demo god. So hopefully this is going to be a smooth ride. So if it doesn't work, I have recorded video, which I use a different voice. All right. So in this case, what I'm planning to demo is a simple set of data where you want to apply some data lifecycle policies. Let's say, in this particular case, what you're seeing is that I have some sample data in my ADLS account that is sitting in hot tier. So if you look at that, that is where it is. Now, for different reasons, what James talked about, right? For cost management or for compliance reasons, et cetera, I may not want to keep the data in hot tier forever or for that long. So what I'm trying to do is I'm trying to come up with a very simplified scenario of how I would do the data management for this set of data. What I'm looking at is, A, I want to tier down this data from hot tier to a colder tier after 2 months. So this is probably, I know that this data is not going to be used after 2 months, so I can afford to tier it down to a cold tier, so I won't incur that much cost. Secondly, for compliance reasons, I want to keep the data around for about 6 months, but I can delete the data afterwards. Again, that is a compliance plus cost reason. So these are the two scenarios that I want to do it. Tear down after 2 months and delete after 6 months. So fortunately, there is an option in Azure, which is called Azure Storage Actions, that you can use to achieve this particular policy. So I'm walking you through that, how to set up that. So if you go to Azure portal, you will be able to search for Azure Storage Actions, click on it, and wait for this page to come, and then create a storage action. So just bear with me while I fill up this thing. And give it a name, action 1. Then we will build the conditions for which we want to govern this data, right? So this page will let you decide or pick and choose the data set where you want to operate on based on the properties of that data. So the two properties that we are looking at is, so the data has to be tiered down after 60 days. So creation time earlier than 60 days. And you add another clause which says access tier equals to hot. So if it is in hot tier and if it is already 60 days, what I want to do is, well, it's already there, so I'll just reuse this. I will set the blob tier to cool, right? So this is the first thing that we talked about, tier down after 60 days. And then you click next. So we have the condition set up, and then we need to create an assignment so that it runs on once or on a periodic basis. So in this case, let me go ahead and create an assignment. Again, type in all the things that you and I'm going to say do tier down now, which is already existing, so I will add a 1 at the end, which also exists. I've done this twice, already know that. Then it is managed by managed identities, and so the question here is, do I need to apply this thing to the entire account, or do I need to limit that to a particular container? So you could, for me, for now, let's do it for the entire account. And I want to run it every day, right? So I set a time, and I'll say this is scheduled for every day. And I'll say repeat every day. And then you have the option to have the report sent it to the same container, or you can create a container and set it there. So I have already created a container called action logs and let the logs flow into that that container. And then I say add. So this is already, the assignment is already added, and it has a schedule. Then you go through the motions of whether you want to add a tag. So once you click here, it will do a validation and enable the create tab. It will do a little bit of the deployment, and the particular action is created. So this is for the first one, right? Tear down after 60 days. Go through the same action, create another one for delete after 180 days or delete after 6 months. Again, same set of things. I'm not going to repeat these steps. So you have 2 actions set up, scheduled to run on every day, and your policy is now enforced, right? Standard forms. So what is it? Once you set up this action and it starts running, the actions will automatically take care of scaling up or scaling down depending on the number of objects that are targeted. So if you have a few hundred objects like I have in the sample database or a few million objects to take care of, it'll scale up accordingly. So you don't have to worry about that. And it will obviously show the reports of each run at the container that you specified, or in the portal itself, you can go and look at some of these reports and drill down to the details of how many objects it targeted, how many failed, how many succeeded, et cetera. So that is, with storage actions, you have a simple and scalable way of making sure that you adhere to the lifecycle policies of your data set. Over to James.
Cool. Thanks, Santosh. And one of the things out there, I was just looking at it, it had acted on 100 files. We want that to be millions of files. And it's a critical element of what Santosh said about the scalability, because there's no point you having to set this up repeatedly and monitor repeatedly to just move a few files around. This is designed to work in the millions and billions of files as we sort of apply these governance policies uniformly across your storage estate. Okay, the third element we want to speak about is how we observe the data and how we observe the use of the data as well. And, typically we think about observability as about sort of understanding the health of the data access. Who is the data being accessed in the way that we expect it to be accessed, and are there anomalies that we need to sort of start chasing down? And also, from a scaling perspective, is the sort of consumption targets what we expect? But then there's the next question about, who is doing this access and what exactly are they accessing? And that now starts to drive insights into the quality of those data sets and where the sort of genuine assets live within your data estate. And then finally, also what we think about from an observability perspective is the ability to diagnose what's going on. A lot of the times, especially as we're busy writing Databricks SQL queries, we're not entirely sure of exactly what the I/O pattern is that is going on in the storage account. And sometimes there's some very surprising outcomes from some seemingly fairly benign SQL statements. And so understanding how that sort of interaction at the Databricks layer maps out at the storage layer and how that can be optimized is also part of that observability arc. But the key thing I want to sort of point out here, and oh no, the slide's not too bad. A lot of the times we think about observing things at the storage account level, which is great. It's certainly important to understand what's going on at the sort of uber macro level. But the reality is you want to be able to drill in and slice by things such as workload, for instance. So, it's a very common pattern for multiple workloads, multiple jobs to be all converging in against the same data sets. And some of those jobs are sort of doing their normal thing. Other jobs are bouncing up and down and so on like that. And so if you're responsible for sort of managing those things and making sure that, the access is as expected, you need to be able to slice things out by workload. And so I will put a disclaimer in here. These are not product slides, but is certainly the way we think about slicing the metrics in order to get better insight into what's going on. And so just blowing up on for instance, the bandwidth consumption, we can imagine multiple workloads down here, and they're all tagged, and so we get that connection information. And now seeing that broken down by workload really starts to help in our understanding of where the load is, where the usage actually is. And similarly, we can do that by user, for instance. You know, if in a lot of cases where there's sort of end users or system principals that are assigned to access this data, you need to be able to understand who is accessing this data and at what rate they're accessing that data. And so observability is an evolving space, and we really want to be able to drive much more into that. But that's just a sort of a hint at the way we're going to start improving the sliceability and the aggregability of the data in order to sort of help better understand. Finally, I want to sort of talk about, at the beginning, you know, we're on a journey with this, and there's certainly what we've seen today is great, but there's obviously room for improvement, room to make things better from an integration perspective so that we see the full stack integrating together, but also the individual aspects of data governance. We want to be able to build that up and sort of continue to be more comprehensive. And so certainly there's areas where we think about sort of immediate opportunities for improvement, and then, as I said at the beginning, this is where we want to have the conversation with you guys to say, okay, what else do you need in order to drive your ability to govern your data? And certainly one of the things is a call out to better integration or better compatibility with open table formats, Delta Lake, Iceberg, Hootie. You know, they all have slight little idiosyncrasies that sometimes, you know, generally work very, very well with object storage systems like ADLS, but other times they're a little bit quirky, and things like the dependency between the transaction log and the data files, when we're replicating those things, can lead to the potential of inconsistent replicas simply because the transaction log gets ahead of the data files and things like that. And so we're certainly seeing opportunities to improve there. Similarly, in the lifecycle management, you would have noticed in the demo, we weren't showing that against Delta Lake because tiering individual files in Delta Lake isn't really a sort of a best practice today. And so we want to be able to support that. We want to be able to track the life cycle of data within a Delta Lake table in order to be able to manage that life cycle at a better granularity. Speaking of granularity, we certainly understand that we need to target the granularity that makes sense to you. And as we saw in that observability, maybe you want to manage things at a table level, maybe you want to manage things at a sort of a workload level or something like that. And you need to be able to apply those policies at that level of granularity. Because as we said before, not all data is equal, and so it doesn't need uniform policy across all data sets. But once you've been able to sort of classify those data sets and bind policies to them, those policies need to be able to enact at that level of the data and not just at the account level or the container level or some coarse grain that may not be applicable for your needs. This week you'll see hundreds of sessions about data catalog federation. A lot of the policy information that we speak about that drives all of this governance is stored in those data catalogs. And today, where catalogs are federating all over the place to sort of build up your complete picture of your data estate, we need to make sure that A, that federation is sort of much more seamless and sort of tight, but also that sort of the result of that federation is now available to the storage service in order for the storage service to act on those policies and do that in an efficient way. And then sort of speaking of sort of integration aspects, we've got to make sure that all of this stuff integrates both vertically and horizontally across the platform in order to sort of really make things. Because, you know, Santosh and I can stand up here as the owners of the Data Lake Storage service and say, oh, okay, we can do a whole bunch of things. But We know we have to integrate with the data catalog. We know we have to integrate with Unity Catalog and Databricks, so that when Databricks queries are running, they're not querying cool data and things like that. All of those sort of end-to-end integrations are certainly elements that we need to go and improve upon. So, in closing, and we'll leave time for Q&A, which I hope you'll all join us in. I really hope that you all leave today with a better understanding and a deeper understanding of how important data governance is. Unless we're treating the data at the sort of level of value that that asset represents in the way that we govern it, we're never really going to make progress with this. We did touch on a few of the capabilities of ADLS, and sort of hopefully you can be all successful in applying those today. And then finally, the ways that we're going to improve, not just in ADLS, but across the entire platform to build out that comprehensive governance stack. And we're going to be relentless in driving this, and hopefully you can sort of come on that journey with us and sort of help fuel that journey, because as I said, it's you guys are the ones that are going to be giving us the requirements to say this is how we govern the data better. Cool, so thanks. I won't dwell on this slide too much, and you should be able to get the links to resources, but there's a number of very good resources in there that, certainly if you're using ADLS in conjunction with Databricks, sort of invite you to go to any of those docs. The Hitchhiker's Guide at the bottom there is sort of often cited capability, because it's not always straightforward in understanding how to organise and manage ADLS, and so there's a lot of good tips in that. So with that, thanks everyone for attending, and
Thank you.
Love your questions.
Thank you.